Okay, today we're going to talk about projectile motion. Okay, those of you who have had or are in physics, what can you tell me?
It goes like that, like because gravity pulls it down, and it has like X and Y and then separate components.
Oh, okay. So we are launching some sort of object with some sort of force into the air, okay? Upward, maybe. And gravity is going to pull it down while at the same time it's traveling forward, okay? So Anthony just mentioned that there's a horizontal and a vertical component, okay? What shape, what graph do these look like? Okay. Parabola. You think of like a slow pitch softball, right? You launch it, goes up, and it comes down. It looks like a parabola. Okay. That is what we are going to be working with. Okay. Now, if we go back to the horizontal and vertical component he was talking about, okay, we are going to have a set of parametric equations. Okay. Where x is representing what about our object? The horizontal distance our object has traveled, and y will represent the vertical distance our object is. Okay, so here is the set of parametric equations for a projectile motion. What are those little circles? Okay. V sub 0, what does that stand for?
Initial velocity.
Initial velocity. That 0 is like the velocity when t is 0. And what about the h sub 0? Is the initial height. Okay, so this set of parametric equations will always give you a parabola. Okay, because our object is going to travel in a parabolic motion. Okay, now since this is a parametric equation, okay, we have direction. So when we actually like graph these curves, it's going to graph where the ball travels. So those arrows are telling you, okay, where the path of the ball, if you will. Okay, now we're going to have initial velocity. It will be in feet per second for this set of equations. Your initial height will be given in feet. Okay. Anthony also mentioned something about gravity. The gravity pulls our object to the ground, correct? Okay. Now, physics people, I'm really sorry, but we're working in feet and seconds. Okay. So gravity is 32 feet per second squared. And so that is where this negative 16 comes from. Okay, so first of all, the pull of gravity is negative because it's pulling down. And so this is gravity over 2. All right, so it'll always be negative 16, but I just wanted you to know where that comes from. All right, so let's look at a parabola. Okay, you are going to always be given an initial velocity, and initial height, so you can set these up and then work with it. Okay. A football is kicked with an upward velocity of 30 feet per second at an angle of 55 degrees. Consider the position of the ball at any time t. We're not going to worry about air resistance. Okay, so the first thing we need to do is set up our parametric equations. Okay. 30 feet per second is what? Our initial velocity. So anytime you see a v sub 0, you're plugging in 30. 55 is our angle. What's our initial height? 0. We're kicking it from the ground. Okay? So our initial height is going to be 0. So x is going to be initial velocity times the cosine of our angle. And y is going to be negative 16t squared plus 30 sine of t, oh no, sine of 55 degrees t. You can write plus 0, but you wouldn't necessarily have to.
Don't we have the x plus 1 by t?
What?
Don't we have 30 plus sine 55 times t?
Oh, yes. Thank you. This needs to be. My mind got distracted. Okay. So, everyone pull out your calculators. Okay. Everyone go to mode. Degrees or radians? We want to be in degrees because our angle is in degrees. Okay? And then do you see where we used to be in polar mode? We can actually change it to parametric mode. Okay? Which means when you press the y equals, you're going to have an x equals and a y equals. So you can punch in our set of parametric equations.
You turn from polar to
Parametric.
that's being
We need to be, yes. If it's not spelled out parametric, it's PAR. So degrees and parametric, and then type in your two equations and stuff. Okay. So now we want to graph this. Does yours look like that? Okay. Our windows are probably different, right? Okay. So let's go to window. You right now probably have 0, and then this is like a 6 point something, right? And then this is like 0.13. Yours looks something like this, right?
Yeah.
Okay, that is great. Now, we can't see the entire parabola, okay? Where did it start? It started at 0, 0, didn't it? So let's change our x, min, and max so we can see maybe more of the parabola. So let's start our x's at 0. And what do you think about how far do you want to stretch it out? What do you think? We want to stretch it out like, because from negative 10 to 10 we couldn't see the parabola coming down, right? So we need more. So would you say 20? 20, 30? What do you want? Okay. Ooh. Not quite. So I'm going to go back to my window and let's, on the safe side, put 35. Oh, no, I didn't do that right. I put 3. There we go. Hey, look at that. Okay? So our football is kicked up in the air and it follows this path. Now, did you see the order in which it was traced? Okay? We don't see any arrows on this, but the order in which they trace it out, that is your direction. Okay? So does everyone's look like this? Anyone having issues? Okay, you let me know how that goes. Okay? Now, I want you to think about what X is representing and what Y is representing. X is representing our horizontal distance from where we start. Y is representing our vertical distance from the ground. Okay? Caitlin, you good?
No, it's not. I don't know what.
Let me look at your equation.
You use it right now?
I mean, it might be in here, but I don't know.
If your window ever looks funny, these tick marks are 1 each. So like Caitlin could only see 2 tick marks because hers was from -2.5 to 2.5. So she couldn't see the entire arc. So we had to change it from -10 to 10. Okay? Yes.
So I don't, once until I started trying to change the name of the maps.
Okay, so go to window. So that key step always needs to be okay, if we go back to this window, this T step, that is like every 0.13, they're plugging in a T. So 0.13, 0.26, point, whatever else. If this number is too big, then you won't get a smooth curve. All right. So if you are ever messing with the window and you don't think it looks right, go back to your T step and make sure that it's like around 0.1 something. All right. So now, the ground. The ground is when what? Y is 0. So whenever Y is 0, we're at the ground. So like this x-axis would represent our ground. That is where Y is 0. Okay? So is our ball really traveling right here? Below the ground? No, it's obviously going to hit the ground, but our functions are still going to model that it's going to keep going, but we know realistically it's going to stop at the ground, right? Okay, so let's look at a couple things. I want to know when the ball will hit the ground. How would I find when the ball is going to hit the ground? Okay, the ground is when our height is 0, so we can plug 0 in for Y to solve for our time. Okay, how do we solve this equation right here? Okay, we have -16t squared plus 30 sine 55 degrees t. What? I wouldn't divide t, but what can we do with t? We can factor out a t. Okay, and when we factor out a t, now we have a product that equals 0. So my first factor I'm going to set to 0, and my second factor I'm going to set equal to 0. So we have a quadratic equation that we started with. We're going to get 2 answers. Our first one, t is 0 seconds. Our second one, I need you to solve this linear equation here. Okay, right, this is just going to be a number. And subtract over, divide by negative 16, what do we get? 1 point what?
1.536.
Okay, which one of these represents the answer we want? This first one is representing what? Where we started, right? Okay, so our football, it takes 1.536 seconds from when we kicked it to when it hits the ground again. So, if you like football, we consider that the hang time, right? How long was it in the air? Okay. Now, what was nice about this is our initial height was 0, which means we didn't have a number right here, right? Let's pretend, just for a couple seconds, that our initial height was, say, 2. How would we have to solve this equation if we did have an initial height other than 0? I would not subtract the 2, okay, because this only works if this is set equal to 0. Okay, so that's not where I would start. What kind of an equation is this?
Oh, okay.
You can't take 2t out because there's no t here. Okay, this is a quadratic, right? Okay, I'm not going to make you factor this because that's ugly. I'm not going to make you complete the square, but you could use the quadratic formula. Okay, so here's your warning. You may have at least one problem where you will need the quadratic formula for. If your initial height is not 0 and you need to find how long your object is in the air, you will need the quadratic formula. If you do not remember the quadratic formula, I bet you can find it in your book somewhere.
This quadratic formula, what do you do with the sign?
Well, like 30 sine of 55 would be your coefficient. So like that is your b value. Okay? 30 sine of 55 is your b value. Definitely. So this is a number less than 1. I would put it in as 30 sine of 55, and then when you're doing the quadratic formula. Okay? All right, let's think about some other things. Next, I want to know how far the ball travels horizontally. How far does our football travel horizontally? What do you mean solve for x? Okay. What is x when y is 0? Do we know when y equals 0? Yes, we just figured out that it took 1.536 seconds for this ball to travel to hit the ground again. So if I want to know how far it went, first of all, horizontal tells us we need to plug a t value in for x. Second of all, we know how long it was in the air, so we can plug in 1.536, right? That is a problem. To get what? And what's our label here?
Which is 0.6.
I was going to say 1.16. 26 point what?
Oh, I multiplied by 5 once.
Okay, okay. Labels are important. Please make sure you put feet. I will be counting off on Wednesday if you do not have feet or seconds or feet per second or whatever it needs to be. Okay. Now let me draw your attention back to your calculator. Okay. If you hit the trace button, notice how it gives you a t value and then the xy coordinate. So like at time is 1 second, then we're 17.2 feet horizontally and 8.57 feet vertically. Okay, we just figured out that it hits the ground at 1.53 seconds. 1.5 what? 1.536. Okay, so yeah, we're about 26.43 feet horizontally and basically 0. Okay, we rounded, right? So this isn't going to be exactly 0 because we rounded. But there you see the cursor is at the axis or on the ground. All right, let's continue. At what time will the ball reach its maximum height? Now let's think about the shape of our curve. What did we say our curve was? A parabola. What specific point on this parabola would represent the maximum height? The vertex. So basically, this is asking at what time is the ball at the vertex. Okay. Now, back in, okay, so we're talking about height. So I'm going to rewrite our y equation here. Y equals -16 t squared plus 30 sine 55. Okay. Now back in first semester, I made you complete the square to put this into vertex form to find the vertex. Okay. I'm not going to make you do that here. Okay. What I'm going to remind you of is what you used in Algebra 2 to find the vertex. Does anybody remember the Algebra 2 way? The x-coordinate, or in this case our t-coordinate, is -b over 2a. Okay. Our vertex is when, we used to think of it as x, but right now it is t, is -b over 2a. Okay. Do you sort of remember doing that? Does it look familiar? Okay. So, in this case, our maximum height, or the vertex, is when t is -b is the coefficient of t, so 30 sine of 55 degrees, over 2 times a is the coefficient of t squared, -16. Make sure when you divide, you either divide by -32 or you divide by parentheses 2 times -16.
Yeah, that's fine.
Make sure you put 37 of 55, close the parentheses, divided by, either multiply to -32 in your head, or make sure that product goes in parentheses. Okay? Anybody have another thought about 0.768 seconds? Ah, okay, I'm going to draw your attention back to the graph. Okay, here was time is 1.536. Here, our time was 0.768. Okay, that is half of the time. Okay, our parabola is symmetric. So since we began at 0 and ended at 0, then our vertex will be exactly halfway through. Okay, so if you know the total time, you can cut that in half. However, please be careful. If we begin at, say, a height of 3 and end at a height of 0, is our graph going to be symmetric about those 2 points? No, and so that would not work in that case. If you begin and end at different heights, you have to use the negative b over 2a. But if you begin and end at the same height, it is fine to use the symmetry and cut that time in half. Just think about what your graph actually looks like.
The negative b over 2a defines the x-coordinate, is that what it
It finds, we used to think of it as the x-coordinate, but our variable is t, so it's the t-coordinate. Okay. So now my last question is, what is the maximum height of the football? Plug it into what? What? Okay, we have the time it takes. What's the actual height? So now we can actually plug this in to our y equation. And what is our maximum height? You ready? Feet. Okay. Somebody kicked a ball. It went 9 feet in the air and 26 feet forward. Was that a good football kick? Maybe they were trying to do an onside kick.
Still no number.
Yeah,
Still
10 yards.
10
Oh,
yards.
you're right. It was short of their 10-yard requirement.
Very.
In the air. Nice try, kid. Right?